Hi kids, we're going to go over the Chapter 5 review questions. They begin on page 264 and the problems are listed. In number 1, there are 5 parts, A, B, C, D, E, and some characteristics are given about quadrilaterals. They want to know what's the most descriptive name. And the way that we interpret most descriptive is kind of like the most inclusive. What name covers all of these characteristics? So part A says a quadrilateral whose consecutive sides measure 15, 18, 15, and 18. So consecutive means kind of in order next to each other. So as you're going around the shape, you're labeling them 15, 18, 15, and 18. Well, this indicates that opposite sides are congruent, which means this one is going to be a parallelogram. So that's part A. Part B says our quadrilateral has consecutive sides that measure 15, 18, 18, and 15. Well, the shape where the congruent sides are next to each other and not opposite each other, that is called a kite. Part C says we have a quadrilateral with consecutive angles of 30 degrees, 150 degrees, 110 degrees, and 70 degrees. If I look at these angles, none of them are congruent. So we don't have opposite angles that are congruent, so we don't have anything from the parallelogram family. It can't be a kite either, because in the kite we have one pair of opposite angles that are congruent. So possibly a trapezoid. If I look at these two angles, they add up to 180. These two angles also add up to 180. So that means these could be my parallel sides. So it absolutely could be a trapezoid. So C we'll call trapezoid. In part D, we have a quadrilateral whose diagonals are perpendicular, congruent, and bisect each other. So they're perpendicular. If they're congruent and they bisect each other, then that means all 4 of these little parts are going to be congruent. This can be none other than a square. And lastly, part E says we have a quadrilateral whose congruent diagonals bisect each other. So we have something like this. And they bisect the angles. So those two angles are congruent. Those two angles are congruent. Those two angles are congruent. And these two angles are congruent. Bisecting angles, the diagonals, when the diagonals bisect angles, that's a property of rhombus. Congruent diagonals are a property of rectangle. So since this has qualities of both, that means it must be a square. The product of a rectangle and a rhombus. That's number 1. The parallelogram in number 2 has the side links that are labeled in red, and it says find the perimeter. So before we can find the perimeter, we need to find the value of x. And we can see that AB and DC are congruent. Opposite sides are congruent in a parallelogram. So we're going to start by setting those two equal to each other so we can solve for x. So we'll subtract x from both sides. X plus 6 equals 8. We'll minus 6 from both sides. So x equals 2. Now we can evaluate those two sides. So AB and DC, if I plug in x here, I'm going to get a value of 10 for both of these segments. My other two sides are 8 and 8. So for the perimeter, I'm adding together 2 10s plus 2 8s. And when we simplify that, we get 20 plus 16, which gives us a total perimeter of 36. Number 3 asks for an inequality stating the restrictions on x. So we need to set up a compound inequality. What we have in our picture is the x plus 50 is in the position of the exterior angle of this triangle, and the 3x degrees is one of the remote interior angles. We know that an exterior angle of a triangle is always greater than either remote interior angle. So we can start off by saying that x plus 50 is greater than 3x. And we know that 3x, that angle's got to be bigger than 0 degrees. So we've got this compound inequality. What we do is we need to get x in the middle, and then, hold on. Okay, excuse me. Scratch this part off. The reason is we haven't talked about solving a compound inequality where x is in multiple parts of it. So let's just start off with just a normal inequality. We're just going to solve for x. So we're going to first get our x's on one side. So 50 is greater than 2x, then we'll divide by 2. So 25 is greater than x, or we can flip that around and state it like this: x is less than 25. X is less than 25, but if we look at our angles, x also has to be greater than 0. Because if x equals 0, then 3 times 0 would give a degree of 0 for this remote interior angle, and we can't have a 0 degree angle. So this are the range of values that x can equal, the restrictions on x. In number 4, we have a rectangle, so we know that the diagonals bisect each other and are congruent, so I've marked that on our picture. We also have an expression for each of our diagonals, which we know are congruent in a rectangle. So PK is 0.2x and JM is x minus 12. So we're going to set those equal to each other. 0.2x equals x minus 12. Now, there's something that you can do if you don't like having this decimal in your answer, or in your equation. You can get rid of it at the beginning. So if I wanted to get rid of the 0.2, I would want to multiply that by 10, and it would just move the decimal to the right once. But if I multiply that by 10, I'm going to need to multiply everything in the equation by 10. So you might choose to start off that way. If not, you can just solve it like you would a normal equation. But if I go ahead and multiply everything by 10, I'm going to get 2x equals 10x minus 120. And that might be easier for some of you. Okay, let's go ahead and solve. So we'll get all our x's on one side. Negative 8x equals negative 120. Then we'll divide both sides by that negative 8. Negative divided by negative is a positive. 8 goes into 120 15 times. So x has a value of 15. But the question says find PK. PK was represented with the expression 0.2x. So all we have to do is plug that 15 into here. 0.2 times 15 gives us 3. So PK has a value of 3. Now, we could have also plugged it into JM's expression, which is x minus 12, and we would also get 3 because they are congruent. So just kind of keep that in mind. Number 6 says we have a parallelogram, and it gives us some information about the angles. Well, we know in a parallelogram the opposite angles are congruent. We also know that consecutive angles add up to 180. So you really have 2 angle measures. It tells us that one angle is twice that of another. Those 2 angles have to be consecutive because they're different. If they were opposite, they would be the same. They wouldn't be twice the other. They would be equal to each other. So the first thing is they're consecutive. Second thing, we know that consecutive angles in a parallelogram add up to 180. For example, these 2 are going to add up to 180. So I could call one angle x, and I could call the other angle 2x, because it's twice that. So to set up the equation, we would just say x plus 2x equals 180 and solve for x. So 3x equals 180. If we divide both sides by 3, x equals 60 degrees. And x, if you recall, was one of the angles. Its angle opposite it will also be equal to 60 degrees. So we've got 60 degrees for this angle and this angle over here. The other two angles are going to be twice that, so they're going to be 120. So if I go around the shape, I would have 60, then I'd have 120, then I'd have another 60, and then I'd have another 120. So these are the 4 angle measures of this particular parallelogram. Number 7 wants to know for each of these 3 cases, are the 2 lines M and P parallel or not? So in order for them to be parallel, we know some stuff about the angles formed by parallel lines and transversals. If you pick any 2 angles, they will either be congruent or supplementary. You just need to make sure you know which one. So on part A, the 100 and the 80, those represent same side interior angles. Same side interior angles are always supplementary. Since these 2 add up to 180, we can say yes, these 2 lines are parallel. Part B, the 2 101 degree angles, these are same side exterior. Same side anything, interior or exterior, are always going to be supplementary. However, 101 plus 101 does not equal 180. So no, these 2 lines are not parallel. Part C, we're going to have to do a little bit more work. If we look at the angles that we have, I can see that the 3x and the x plus 40 should be congruent if the lines are parallel because they're alternate interior angles. So we could start off by setting them equal to each other. Well, we don't know if they're equal. Okay, so let's think about what we do know. We know that the 120 with the x plus 40, those are supplementary because they form a linear pair. They're right next to each other. So that is something that we do know. We could start off with that. We could say 120 plus x plus 40 will equal 180. And then when we solve this, we get x plus 160 equals 180, which means x has to equal 20. So now I want to take that 20 and see if the other angle, the 3x, is going to be the same as the x plus 40. If we plug into 20 into both of those, we will get 60 degrees for each of those angles. So since those 2 angles are congruent, we can say that M and P are yes parallel for part C. When you have this type of this type of problem, always start with what you know for sure is true. So originally I had started by saying x plus 40 equals 3x. Well, they would only equal each other if we knew the lines were parallel. We're trying to figure out if they are. So that would not be a good way to start. One thing that's always going to be true, if you have 2 angles that together form a line, like the 120 and the x plus 40, those will always add to 180. So that will always be true. Another type of angle pair that is always going to be congruent are vertical angles. So vertical angles would be like this and this. If you see those 2 types, those are always going to be congruent. So you could always start with that. Number 8 says name 5 properties of a parallelogram. We know that there are only 5 properties. One property says that opposite sides are congruent. Another property says that opposite sides are parallel. Another property says that the diagonals bisect each other, so we can show that like this. A fourth property says that opposite angles are congruent. So this angle and this angle are congruent. This angle and this angle are congruent. And then the fifth property says that consecutive angles, so like this angle and this angle, are supplementary. They add up to 180 degrees. Those are the 5 properties of a parallelogram. Number 11 says to show that this shape is an isosceles trapezoid. Well, first of all, in order to be an isosceles trapezoid, we first have to show that it's a trapezoid, which means all we have to show is that we have a pair of opposite sides that are parallel. So the cool thing about graphing these shapes is that they're pretty much drawn to scale. So if I'm looking for the sides that I think could be parallel, I would look at BC and AD. And to determine if they're parallel or not, I'm going to take a look at their slopes. The other cool thing about a graph is you can actually count the slope using the rise and run. You can of course use the slope formula, but sometimes counting is a little bit easier. So if I look at the slope between B and C, I'm going to go up 4, and I'm going to go to the right 4. A rise of 4, so let's see, I've got a rise of 4, a run of 4, that simplifies to 1 over 1. There's the slope of BC. If I look at the slope of AD, I'm going to rise and run, let's see how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I'm going to run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So if I simplify this slope of 13 over 13, we also get a slope of 1. So because those two slopes are congruent, we can say BC and AD are parallel, which means, yes, we do have a trapezoid. Now we need to figure out, is it an isosceles trapezoid? There are a couple ways we can prove we have an isosceles trapezoid. One, we can show that the diagonals are congruent. If I drew in the diagonals or sketched them, we're going to have to use the distance formula to figure out their lengths because they are both at an angle. So another option we have is to show that the legs are congruent. And by legs, we would be talking about CD and AB. Well, CD and AB, the cool thing about both of those segments is that CD is completely horizontal, BA is vertical, so we can just count the length of those. It's probably going to be the easiest thing to do. If those are congruent, then we have an isosceles trapezoid. So CD has a length of 1, 2, 3, 4, 5, 6, 7, 8, 9. BA has a length of 1, 2, 3, 4, 5, 6, 7, 8, 9. So because those two segments are congruent, yes, we've got an isosceles trapezoid. Number 13 is a probability question. It says 2 polygons are selected at random from a group consisting of a non-isosceles trapezoid, an isosceles trapezoid, and a parallelogram. So we've got these 3 shapes. We're picking 2 of them. So first we need to come up with all the possibilities. So to make it easier, I'm going to just label these so I know what I'm referring to. So we could either pick A and B, we could choose A and C, or we could choose B and C. So there are three pairs we could choose from here. It says find the probability that both polygons have 2 pairs of congruent angles. Well, in my A shape, the non-isosceles trapezoid, there is no certainty that we have any angles that are even congruent. So anything with A, we're going to get rid of. In B, an isosceles trapezoid, these 2 upper angles are congruent, and these 2 lower base angles are congruent. So we do have 2 pairs of congruent angles. In a parallelogram, opposite angles are congruent. So again, we do have 2 pairs of congruent angles. So anything with B and C would work. We have 1 pair. So out of those 3 choices, 1 works. So there's a 1 in 3rd chance that we'll pick a pair of these quadrilaterals that have 2 pairs of congruent angles. In number 14, part A, we have this picture. It says how many squares appear to be in the figure at the right. So I think it wants us to make some assumptions about what looks like a square. Of course, I've got the big square. There's 1. I've got these four little squares, so that makes 5. And then I've got this guy that looks like a square, so that makes 6. So we've got 6. Okay, part B says how many rectangles. Now we have a lot more options. Well, we've got those 6 squares that we just said. Squares are rectangles, so those will count. So we've got 1, 2, 3, 4, 5, 6. Then we also have 7 and 8. So those are the obvious ones. Let me switch colors. So 8 obvious, and then let's see what else we've got. We've got 9, 10, 11. Then we could put the top half together and get 12 on the top. Do that with the bottom. There's 13. We could put the bottom 2 right together. There's 14. We could do the right side. Let me get another color. So there's 15. We could do the 4 squares together. There's 16. I could do 3 of the squares together. There's 17. I could do these 3. There's 18. And then I could do the 2 lower right squares with the bigger square. This one right here. There's 19. Okay, number 16 says we've got a parallelogram. So we know that opposite angles are congruent. So we've got 2 sizes of angles here. When you label these vertices for a parallelogram or any quadrilateral, and you don't have a picture, you need to label them consecutively. So you're going around the shape, either clockwise or counterclockwise. So we have expressions for angles A and B. Those are consecutive, which means they're going to add up to 180. So we're going to use that to help us create an equation here. Oops, I can't write it right here, sorry. These add up to 180. So we will start off by saying 2x plus 6 plus x plus 24 equals 180 degrees. If we combine like terms, we get 3x plus 30 equals 180. Move our constants to the right, so we'll subtract 30 from both sides. 3x equals 150, and then we'll divide both sides by 3, so x has a value of 50. It says find the measure of angle C. Well, angle C is across from angle A, so those two have the same measure. So the measure of angle C is going to equal the measure of angle A, which is 2x plus 6. But now that we know that x is 50, we'll just plug that in. 2 times 50 is 100, plus 6 is 106 degrees for the measure of angle C. Number 17 asks for the area of the circle. It says to 3 decimal places, but I never want you to round area or circumference. Anything with pi, always keep it in terms of pi. So the formula for area of a circle is pi times radius squared. So in order to find this, we need to figure out what the radius of this circle is. I can see 2 radii right here. No, they're congruent. If I look at the horizontal distance or horizontal change from T to P, which is the diameter, because it goes through center O, we're going from a 2 to a 12, which means the diameter is 10, which means the radius is 5. That's the number I'm going to plug in for R. So we're going to get pi times 5 squared. 5 squared is 25. You just put that in front of the pi. So the area is 25 pi units squared. Super simple. So for number 18, we're just given this quadrilateral. All we know is that AD and BC are parallel. So at this point, it could be a trapezoid, might be a parallelogram, but we need to know some more information. So what I'm going to do is I'm going to highlight my parallel sides and a transversal. I know some expressions about for each of the 4 angles, 1, 2, 3, and 4. So the transversal that touches all of those angles is the one from D to B. Now, if I'm looking at these three yellow lines, the only angles that are formed by the lines are angles 1 and 3. Those are alternate interior angles, which means they're going to be congruent because my lines are parallel. So I'm going to start off with that because that's what I know. Part A says find the measure of angle 1. So angle 1 has a measure of, or an expression, 5.63x plus 2.42. That's going to be equal to the measure of angle 3, which is 6x minus 5.1. So this is the equation we need to solve, and I know a lot of you are scared because you see the decimals. So you have a couple of choices. The greatest decimal place is the hundredths, so you could multiply every single thing in the equation by 100 so you get whole numbers to work with. That's one option. Or you just leave it as decimals. It might actually be easier to multiply by 100, but let's just not do it. Let's just see what happens. So the first thing, we want to get all our x's to one side. Now if you're going to leave them as decimals, you need to be very careful. You might want to get out the calculator to help you. So I'm going to subtract 5.63 x's from both sides. So I'm going to end up with 2.42 on the left equals, I need to be very careful when I subtract 5.63 from 6. I've got to line up the decimals. So like if you're doing this on your paper, it would look like this. You'd have to line it up like that. And then you would have to borrow, and you would get 0.37. If you want to verify that in your calculator, you certainly could. So 0.37x minus 5.1. Then we need to move our constants to the other side, so I'm going to add 5.1 to both sides. Make sure that you're lining up those decimals. So what you're going to get on the left, you're going to bring that 2 on the right part of 2.42 down. The 4 and the 1 add to 5. And the 2 and the 5 add to 7. So 7.52 on the left equals 0.37x on the right. So if we divide both sides by 0.37, I can't really fit it down here. What you're going to get an x value that equals 20.324, and those three numbers keep repeating. So now for part A, to finish it up, we're supposed to evaluate the measure of angle 1. Well, angle 1 was equal to 5.63 times x plus 2.42. So I'm going to come up here. 5.63x plus 2.42. Probably going to need your calculator here. So what you can do is this 20.324 repeating, if you just leave that in your calculator so that it's not rounded, and then you just multiply that by 5.63 and then add the 2.42 to it, you're going to get something that's approximately equal to 116.85. That is the measure of angle 1. That's an approximation. Okay, so part B wants to know, is DC parallel to AB? Well, recall that we found an x value that equaled 20.324, those three numbers repeating. We have expressions for angle 2 and angle 4. Now, if DC and AB were to be parallel, so let's just for a second think that they might be parallel. Let me get a different color here. Okay, so if these two are parallel, and I've got this transversal, then that means that angle 2 and angle 4 should be congruent. Well, it says that angle 2 equals 2.1x, and angle 4 is 42 degrees. So if I plug in this value for x right in here to the 2.1 times x, if it equals 42, then it's going to be, those two lines are going to be parallel. But if I multiply 2.1 times that number up here, times this guy, it does not equal 42. So what that means is DC and AB are not parallel. Number 19 has 4, always, sometimes, never. Let's look at part A. It says if the diagonals of a quadrilateral are congruent, the quadrilateral is an isosceles trapezoid. This is going to be a sometimes, because when the diagonals are congruent, it could be some sort of rectangle. And a rectangle and a trapezoid do not overlap in our Venn diagram, so that's going to be a sometimes. Part B says if the diagonals of a quadrilateral divide each angle into two 45-degree angles, the quadrilateral is a square. So let's think about what that could look like. If the diagonals bisect or divide each angle into two 45 degrees, so this is 45, this is 45, this is 45, this is 45, and so on around the shape, we definitely have a square. This is going to be always. Part C says if a parallelogram is equilateral, it is equiangular. Well, equilateral means all its sides are congruent. A parallelogram that's equilateral is a rhombus. Rhombuses are only equiangular if they're squares, meaning their angles are all equal if it's a square. And just a normal rhombus, the angles are not equal. So this is going to be a sometimes. They're only going to be the same if they're square, or equilateral and equiangular. D says if two of the angles of a trapezoid are congruent, then the trapezoid is isosceles. So we've got this trapezoid. It didn't say which two angles. So if these two angles were congruent, then we would have an isosceles trapezoid. So that would be true. However, if these two angles are congruent, these two don't necessarily have to be congruent, which means it could just be just a trapezoid, not isosceles. So this is going to be a sometimes. Number 22 wants to know the most descriptive name for this quadrilateral. Because I've graphed it, I can get a pretty good idea of what it looks like. To me, it looks like a square. But according to 5.7, in order to prove that it is a square, we need to first prove that it's a rectangle and a rhombus. If I look at the test for rectangle and rhombus, there's a rhombus test. There's one that says if the diagonals of a quadrilateral are perpendicular bisectors, then it's a rhombus. I don't have to prove first that it's a parallelogram. So I'm going to go ahead and first try to prove that it's a rhombus, and then I'll try to figure out how to prove that it's a rectangle. So the test I'm trying to figure out is, are the diagonals perpendicular bisectors of each other? There's two components. To be perpendicular, they need to have opposite reciprocal slopes so that they form right angles. Then they have to be bisectors of each other, which means they have to share the same midpoint. So I've got 3 calculations to make. Let's go ahead first and see. Ooh, I wonder if they do cross on the x-axis, or if I just drew that like that. Let's go ahead and first see if they are perpendicular. So if I look at the slope, the first diagonal that I drew, if I look at its slope, this one right here, I'm going to use the x and y coordinates from the endpoints. So I'm going to subtract my y, so I could do 6 minus negative 6. And then my x's, 4 minus 0. That gives me 12 over 4, which simplifies to 3 over 1. There's my slope of one diagonal. Let's look at the slope of the second diagonal using the coordinates of its endpoints. If I subtract my y's on the top, I get 2 minus negative 2. My x's on the bottom, I get negative 4 minus 8. These simplify to 4 over negative 12, which then again simplifies to negative 1/3. If I look at these two slopes, they are opposites, one's positive, one's negative, and they're reciprocals of each other. So I am confident in saying that these two diagonals intersect at a right angle. Now the second part of that rhombus test is to determine if they are bisectors of each other, which means they're going to share the same midpoint. So let's take a look at both of the midpoints. We'll call it M. So the M of my first diagonal that I drew, remember how to find midpoint. You're going to average your x values and average your y values of the endpoints. My x values are 4 and 0, so I'm going to add those, divide by 2. My y values are 6 and negative 6. I'm going to add those, divide by 2. Oh my gosh. I can't push that button. Okay, so what I'm going to get is, for my x value, 4 divided by 2, which is 2. My y value, 6 plus negative 6 is 0. 0 divided by 2 is 0. So I'm going to get a midpoint of 2, 0, which is exactly where the two intersect. Now I'm going to take a look at the midpoint of the second diagonal I drew. And for them to bisect each other, they need to have the exact same midpoint. So I'm going to average those x values of those endpoints. Negative 4 plus 8, those are my two x values, divide by 2. My y values are 2 and negative 2. Divide those by 2. For my x value of my midpoint, negative 4 plus 8 is positive 4. 4 divided by 2 is 2. And for my y value, 2 plus negative 2 is 0. 0 divided by 2 is 0. So they do have the exact same midpoint, which means they do bisect each other. So yes, we've got a rhombus. If I can also show that this is a rectangle, then it will be a square, because it'll be a rhombus and a rectangle. So let's take a look at the rectangle tests. Okay, so for the rectangle test, the test that I'm thinking is the one where I don't have to first prove it's a parallelogram. It says if all 4 angles of a quadrilateral are right angles, then it is a rectangle. So for all 4 to be right, that means consecutive sides, or sides on either side of that supposed right angle, must have opposite reciprocal slopes. So I need to take a look at the slopes of the 4 different sides. Let's go ahead and start with this top left side. For the slope of these, I'm just going to go ahead and count the rise and the run. I see a rise of 4 and a run of 8. 4 over 8 simplifies to 1/2, so this has a slope of 1/2. Its opposite side has a slope of also 4 over 8, which gives it a slope of 1/2 as well. Let's take a look at the other two sides. Those both look like negative slopes because they're going down from left to right. So the rise is going to be 8, or I can think of it as a negative 8, and the run is 4. So this has a slope, remember that it's negative, of negative 8 over 4, which simplifies to negative 2 over 1. And if I look at the slope of its opposite side, I also have a run of 4, a rise of 8, but remember it is negative. So negative 8 over 4 also simplifies to negative 2 over 1. And if I look at consecutive sides, sides next to each other, they all have opposite reciprocals. So like, for example, this side and this side, their slopes are opposite reciprocals. So that means in this box right here, in this corner, there's a right angle. Then if I take a look at, another pair of consecutive sides, they're also going to have opposite reciprocal slopes, which means there's going to be another right angle and so forth around the shape. So because of that, this is not only a rhombus, but it's a rectangle. And the test for square said that if you were both of these, which we are, then we have a square. Yay! For 25, we need to find the value of x, and if you look at this, we've got two parallel lines, and the transversal changes directions twice, so this is a double crook. So the first thing we're going to do anytime we see a crook or a double crook is we're going to draw auxiliary lines right through the crook, and these auxiliary lines are going to be parallel to the other two lines. Then in this case, this is going to split our picture up into three different parts, and we're going to start with the part that we have the most information about. So I'm going to start on the bottom. If I cover up all of the area above that bottom red line, so let's just say we're going to cover all this up, just ignore it. This 20-degree angle is going to be congruent to the bottom part of this 50-degree angle. So this bottom part is 20 degrees, which means that the top part of the 50-degree angle has to be 30 degrees. Okay, so now let's take a look at the middle section between here and here. So ignore above and below the two red lines. If this angle is 30 degrees, then this bottom part of angle x is also 30 degrees because those are alternate interior angles, much like the 20s. So the bottom part of angle x is 30 degrees. Now to find the top part of angle x, we're going to just focus on this top section and ignore everything below it. This 140 degrees, let me switch up my colors. This 140 degrees along with the top part of this x, these are same side interior angles, which means they're going to be supplementary, they're going to add to 180. So that means the top part of angle x is going to have to equal 40 degrees. So to figure out the total measure of angle x, we're just going to add the 40 and the 30 together. So x is 70 degrees. 27 is a probability question. We have 5 angles labeled. We've got 2 parallel lines and a transversal. We know when we have 2 parallel lines and a transversal that any of the angles formed, any two, are either going to be congruent or supplementary. And we color-coded them a certain way. So if they were the same color, they're going to be congruent. If they're supplementary, they're going to be different colors. So, for example, 1 and 3 will be the same color, and these two will be the same color, but those aren't labeled. The other 4, angle 2 and this one, and then angle 4 and angle 5, those are also going to be congruent. So if I pick a red and a blue angle together, they're going to be supplementary. So let's go ahead and list all of the possibilities. I said if 2 of the 5 labeled angles are chosen at random. So I'm going to list all the possibilities. I could pair 1 with 2, 1 with 3, 1 with 4, 1 with 5. Or I could pair 2 with 3, 2 with 4, 2 with 5. Or I could pair 3 with 4 or 3 with 5. Or I could pair 4 with 5. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possibilities. That's going to be our denominator, excuse me. We need to figure out what is the probability that they will be supplementary, the pair will be supplementary. So I've got to look at the colors. So I'm going to circle them if they're going to be supplementary. So let's see. 1 and 2 are different colors, so those are going to be supplementary. 1 and 3 are the same colors, so they're not. 1 and 4 are different colors, so those will be supplementary. 1 and 5 are different colors, so those are going to be supplementary. 2 and 3 are different colors, those are supplementary. 2 and 4 are the same colors, so they're congruent, they're not supplementary. 2 and 5 are the same colors, so those are congruent, not supplementary. 3 and 4 different colors, those are supplementary. 3 and 5, different colors, those are supplementary, and then 4 and 5, those are the same color, so those are not supplementary, they're congruent. So if I count the ones that I circled, I've got 6 out of the 10, and that reduces to 3/5. There's a 3/5 probability that if I choose 2 of those 5 angles at random, they will be supplementary. For number 30, the last problem, yay, it says we have a kite. It says find the 3 possible values of the perimeter of the kite. Well, we don't know exactly how this kite is oriented. We don't know where the line of symmetry is. So let's suppose that the line of symmetry is how we drew it in our notes, like this. If that's the case, then that means these 2 segments will be congruent and these 2 segments are going to be congruent. So let's go ahead and start there and see what happens. If we have this case, then that means y squared equals 5y plus 6. Since this is a quadratic, as I see that squared symbol, I'm going to move everything to the left and I'm going to factor y squared minus 5y minus 6 equals 0. I'm going to factor this left quadratic trinomial into 2 binomials. Because my y squared has a coefficient of 1, I'm going to put y and y at the beginning of my 2 binomials. Now I need to look at the factors of my constant, which is -6. So 2 numbers that will multiply to make -6, but that will add to the coefficient of my middle term, which is -5. So I'm thinking -6 and +1. -6 times +1 is -6, yes. And -6 plus +1 is -5. So I'm going to put those 2 values here, -6 and +1. What we're going to do now is we're going to set each of those binomials equal to 0. So I'm going to come up here. So we're just going to make 2 little equations. Y minus 6 equals 0 and y plus 1 equals 0. If I solve both of these, I get a y value of 6 and a y value of -1. I get 2 y values. So what we're going to do is we're going to evaluate the perimeter of the kite for the 2 different y values. Let's start with y equals 6. So if y equals 6, then 5 times 6 is 30 plus 6 is 36. Y squared, or 6 squared, is also going to be 36. My other 2 sides, which should be congruent, are both equal to 2y plus 3, or 2 times 6, which is 12, plus 3, which is 15. And they will both equal 15 because they'll both be congruent. So one perimeter, using y equals 6, is going to be 36 plus 36 plus 15 plus 15, which is 102. There's one perimeter. Okay. Now, let me go back a sec. Okay, so one perimeter was 102. Now, if we evaluate the perimeter again, but this time using y equals -1, let's see what happens. So if I put -1 here, 5 times -1 is -5, plus 6 is +1. Y squared, or -1 squared, is also 1. The other 2 sides both equal 2y plus 3, or 2 times -1, which is -2, plus 3, which is 1, which means this one is also 1. If I add those 4 together, I'm going to get a perimeter of 4. So there are 2 possible perimeters when my picture looks like this. But we can also look at this picture a little differently. Let's suppose that our line of symmetry was like this. So kind of turn your head so you can see it a little bit differently. The sides that are now going to be congruent are these 2 sides and these 2 sides. So this time we're going to start off with a different equation. Y squared is now equal to 2y plus 3. Whoops, plus 3. Because it's also a quadratic, we're going to move everything to one side, so 0's on the other, so we're going to get y squared minus 2y minus 3 equals 0. This quadratic trinomial on the left, we're going to factor into 2 binomials. We're going to put y and y, since our y squared term has a coefficient of 1. We're going to look for factors of our c, which is -3, that will add to make our b term, which is -2. So factors of -3 could be -3 and 1. Those will multiply to make -3, and they will add to make -2. So we're going to use -3 and 1. We're going to set both of these equal to 0. Y minus 3 equals 0. Y plus 1 equals 0. And then when we solve these, we get y is +3 and y is -1. Now y is -1 was one of the solutions when we solved it the other way. So we've already evaluated this solution. That gave us the perimeter of 4. Now we just have to evaluate when y is 3, and then we're done. So again, if we plug in 3 for all our y's, for 5y plus 6, we get 5 times 3, which is 15, plus 6 is going to give us 21 here, which means this other side is going to be 21. If I look at the other two sides, y squared, or 3 squared, gives me 9. If I plug in y right here with 3, 2 times 3 is 6, plus 3 is 9. And if I add up those four numbers, 21, 21, 9, and 9, we get a perimeter of 60. So these are the 3 possible perimeters for this particular kite. Please bring any questions that you have to me before Friday, or possibly right before class on Friday. I do have tutoring Friday morning if you need to go over any last minute things. Good luck, study. If I were you, I'm going to give you a note card in class. I would write all my properties on the note card with pictures and possibly all my tests. I would also draw that parallel line and transversal picture with the different colors, the 2 alternating colors. I think those 3 pieces of information could be very useful to you. Good luck on your tests. Love you.